another problem. So in this problem, we are going to discuss about some different solid. It's a special type of problem. So far only one time asked in KTU. Draw the isometric view of a hexagonal pyramid, 35 mm edge of base and height 70 mm resting with its base on HP. It is truncated by a surface which is inclined at 30 degree to HP and perpendicular to VP. This plane passes through the midpoint of the axis of the pyramid. So first understand the question very clearly. It's a truncated solid. The truncated solid of hexagonal pyramid. So first information given in the problem is it's a hexagonal pyramid. Hexagonal pyramid. You know that how it will be. Then 35 mm base edge size is given, 35 mm side, 35 mm side, 70 mm height. So these are the information given about the hexagonal pyramid. The next one is resting on the HP. So entire solid is resting on the HP. On HP. Then first full stop is over. So the entire thing is we consider as a projection of a solid. It is truncated by a surface. Truncated in the sense cut by a surface which is inclined 30 degree to HP. So 30 degree to HP perpendicular to VP. So you have to cut the solid at 30 degree inclined to HP. So this is the condition given. I first draw the front view and the top view of the particular condition. So it's a hexagon. Remaining conditions are not given. You can select in any format. Okay, it's a pyramid, so you can connect all the points. Connect all the corner points with the apex point so as to indicate the edges. Okay, now we can name it as 1, 2, 3, 4, 5, 6. Then draw the center line. Then complete the front view. Front view is over. So this is the apex point O dash. 1 is visible here, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash invisible, 6 dash invisible, because 5 dash and 6 dash coming back side of the pyramid. So it is coincide with the point 2 and 3. So no need to indicate here, put within the bracket. Now it is cut by a truncated surface. It is cut by a sectional surface which is 30 degree inclined to HP and bisect the center. 30 degree inclined to HP perpendicular to VP, and the plane passes through the midpoint of the axis of pyramid. So first to find the midpoint. Let's assume this is the midpoint. Now draw the line which cuts 30 degree inclined. So this particular sectional line is passing through the midpoint of the hexagon. Finally, we will get some different point. You know that how to do the problem in section. So these are the edges are visible. Okay. Then accordingly you can construct the cut point also. First cut point, second cut point, third cut point on next edge, fourth cut point. So we will get obviously 4 different cut points. 1, 2, 3, 4, 5, 6. Then connect it. This is the section. Okay. Now our question is not construction of sectional plane, not construction of sectional front view or true shape. Now our ultimate purpose is construction of isometric projection. Suppose if the solid is cut by some surface, cut by some truncated surface, the remaining portion can be drawn with the help of isometric projection. Now I go to the projection. So what to do? First draw the entire pyramid. You know the condition, how to construct it. For that we need the box. Make it as a box. Okay, then here also you can convert into box. You know the height is 70 mm given. This side, it's obviously 2 times of its side 70 mm. You have to measure this value. It probably coming nearer to 50 mm. Okay, you measure the value from the diagram. Okay, after making everything as a regular, go to the box construction. First construct the isometric axis. So here isometric axis are 30-degree inclined. Then height component, height is given as 70 mm. You can fix directly 70 mm here. Then 70 mm another one side. Any one side, you can take any one side, no issue. I am taking this side 70 mm. Then 50 mm this side. So this side is 70, this side is 50. I am considering that is the front view. Okay. Then construct the box. What to do? Draw the vertical line. Draw the vertical line of this particular point. Then connect it. You know how to construct a box. So that's all about a box. Now we got the box. Next, what to do? Find the center point. So in the top surface, exactly at center that is available. See here, this is the point, center point. Find the center point. So this is the center. Then identify the points 1, 2, 3, 4, 5, 6 on the bottom surface. In the bottom surface, obviously, center point is the first one, point number 1. Here 2, you can measure the value. It come around, so this value is 35. So 17.5, 17.5. So put 17.5, 17.5. Point number 1, 2, 3. In bottom, back side also it is possible. So find the center point 3. So 4 is the point. Then if you draw the line, you will get here another 2 points, 5 and 6. Now after this one, you can directly connect whatever you want. First edge, second edge is visible, third edge is visible, fourth edge invisible, sixth edge is visible. Then connect the base edges. So these are things are available. Remaining things are invisible. Now, how to find the exact cut points? That is very most important thing. So construction of pyramid, you know that already how to construct the pyramid. Now our requirement is finding out the cut points. Finding out the cut points exactly. How to find out the cut point? See here, I will explain first point. This is my first cut point. Let consider A, B, C, D, E, F. 5 cut points are available. The point A is available here. We can fix it here also. A, B, C, D. E is available backside and F also in backside. Now we have to transfer this data to the isometric projection. How to transfer? See here, this particular point A is available in a same line. Point A and D is on the same line. First draw the particular line here. I will use black pencil, sir, black pen for this. I can draw one line. This is the line indicates 1 and 4. Okay. In this particular line, measure the distance. Measure this particular distance. 1 to A. Measure this particular distance and fix it over here. Let's use some other color for easy visualization. This is my first point. Okay. Then what to do? If you project directly, it will. This is the point. This point is called A. So this point is available here. A. Now what happened? If you draw the vertical line, definitely that will hit the prism. Now you have to draw the vertical line. So this is vertical line. Draw parallel of this one. That definitely hits here. Okay, first cut point is over. Is it clear? Once again I will repeat. First find the point A. The point A is available on a line 1 4. So first construct the line 1 4. In the same line, measure the distance of 1a. Measure the distance of 1a in the top view. Fix it here. This is 1a. After finding out, you can name it as a. Okay. The a line, if you project the vertical line, that definitely hits the slant edge. That definitely hits the slant edge. Similarly, draw the vertical line that definitely hits the same point here. So this is the point of A actually. Actual point is A. In front direction we can say it as A dash, no issue. Then I can do the same thing for D also. Measure the distance D to 4. Measure the distance D to 4. Then fix it over here. I will get D here. Okay. This particular D, this particular point D, cut the edge O4. O4 is available or not? If it is not available, then connect it. This is the thing actually. Now draw the vertical line. Draw the vertical line. So this is my vertical line. It will hit here. Okay, this is the point D dash. You can put dashes. Second point is over. Then B. Where exactly B is available? You have to find the way for this. Measure the distance of this one. Measure the distance from the side surface. So here this surface is available here. Then I can draw one more line. Measure the distance. Draw one more line. Like this. So this distance is equivalent to this distance. Measure this distance. Then measure this particular distance from point 1 to B. Measure the distance. So point 1 is available here. Then point 1 to B. You can fix that point by directly measuring from the top view. Fix that point B here. Okay. What happens if you project? That definitely hits a line on either 2. So this is on 2 actually. Hit on either 2. So this is my 2. If you project, what happened? It definitely touches here. This is my line 0, 0, 2. This line is 0, 2. Then go to the next point C. Do the same thing. Measure the distance from here. If it is in a straight line, no issue. But if it is not in straight line, you have to measure the distance. Then fix it over here. Then measure the distance of 4 and C, this side. For understanding purpose, I am drawing a lot of lines. In your case, you can measure it. Okay. Fix the point C. Fix the point C. Then project it. Two different lines are available. Okay. Then follow the same procedure for F and E also. Measure the distance. This is my F. Measure the distance from the diagram. Fix it here. Then draw the vertical line that will hit here. So F dash. This is my F dash. Then E on other side. If it is in the same line, no issue. Measure the distance. This distance. Measure this distance 4 to E. This is 4 line, 4 to E. This particular point E hits the line O5. So O5 is available backside. O5 is available backside. If you draw the straight line, definitely hits here. This is E dash. Now they got all the points. So what are the points? A dash, B dash. So A dash is available. This is B dash. Then C dash. Then D dash, E dash, F dash. After identifying all the cut points, just connect it. First cutting. second, third, B, next C. Okay. Now after completing this one, you can darken the area whatever required. I will just erase for your understanding purpose. You can easily find the exact diagram. Now is it clear? Now this is the surface, slant surface we have here. Okay, the procedure is so simple. First to find the point ABCD. Fix that point ABCD on the base. Then draw the vertical lines. That vertical line definitely hit the slant surface. Okay, this particular point A hits the A dash here. Okay, you can do the same thing here also. So that's all about this problem. Once again I will repeat. Put all the points A, B, C, D in the top view. The same points are visible here also. A dash, B dash, C dash, everything is available. Okay, first fix the point A. Measure the distance from the point 1 to A and to fix it over here. So everything you have to copy, retrace it. You have to trace all the points here. This is the point A, B, C, D, E, F. First find the points A, B, C, D in the base surface. Then draw the vertical lines. This particular line, so this indicates the vertical line. You can directly measure it, otherwise just draw the vertical line. If you draw the vertical line, definitely that hits the particular edge. Find the cut points, A dash, B dash, C dash, everything. So that points are available here, A dash, B dash, C dash, D dash, E dash and F dash. After identifying all the points, just connect it. This surface is the sectional surface. So I can say it. So this is the sectioned surface. Okay. So for only one time, KT University asked this kind of question. So with this question, I'm going to complete the entire isometric projection. Okay. So in this particular topic, we had discussed about the construction of prism, construction of pyramid, construction of sphere, construction of cylinder, construction of cone, construction of pyramids. So these are the major varieties. Apart from that, combination of various solids. Next one more variety. The third one is this kind of problems, truncated solids. This particular solid is considered as a truncated solids. Okay, I hope you have understood the isometric projection very well. If you have any clarification, if you have any doubts, kindly ask me. Okay, I will ready to solve any kind of doubt. Thank you all.